Today I am going to talk about digital communication system, and here the course is divided into 5 modules. In that I am going to handle now module 1. So module 1, it will cover the topics like digital pulse modulation. The subtopics in that module are elements of digital communication system, elements of PCM, companding, differential PCM, or we can call that as DPCM, delta modulation's advantage, disadvantage, adaptive delta modulation, then comparison of PCM and delta modulation system, and noise in PCM and delta modulation system. So before going to the topics, first I will let you know what is the communication, meaning of communication. So communication, actually it is nothing but transferring of data reliably from one point to another. So the data could be voice, video, codes, etc. So here in the basic communication system, it consists of the blocks which is called as information source. The source actually generates the signal and then it goes to the transmitter. The transmitter, it is having many blocks inside that, which is capable of converting the source signal into a signal which can be transmitted via channel. The next block in this communication system is channel. Channel may be wired or wireless channel. And then coming to the receiver, it gets the signal from the channel and then again it converts back to the signal which was given in the information source. So, and that is nothing but we are going to get in the information sink. So here, so the description about the information source, transmitter, then channel, then receiver, etc. given here, and this is the typical digital communication block diagram. So here some of the blocks are given as, some of the blocks are here, it is essential block, okay, and some of the blocks are it is optional block. So we can see here the shaded blocks are optional, but this non-shaded blocks are essential blocks. So essential blocks means they must be there in the communication system, like format, then modulation, then that is detection, and then information sync, again that format. These are the essential blocks. So here we can see that here on the top, at the top we are having the format, then source encoding, encryption, channel encode, multiplex, modulation, then again bandpass modulation, then frequency spreading, then multiple etc. Then it is given to the transmitter. From transmitter to the via a channel it is coming to the receiver, and at the receiver the opposite of the operation of the blocks which is given on the upper arm is performed here in the down arm. That is multiple, actually it is D-access, frequency despread, demodulation, demultiplex, channel decode, decrypt, source decode, etc. So explanation of these blocks are given here. So here we can see that. So here what is that? First is the formatting block. So formatting block is nothing but the block which is essential for source information, for converting or the transforming the source information into digital symbols. Then it is given to modulation. Then again after modulation, it is modulation is the process by which symbols are converted into waveforms and are compatible with the communication channel. So here actually formatting steps produces A to D conversion, source encoding, and source encoding is nothing but it eliminates the redundant information present in the signal. Then after that here we can see that there is a block called encryption, which prevents unauthorized user for understanding the message. Then we are having channel encoding. Then channel encoding mainly for removing or reducing the bit error rate, and then frequency spreading, etc. are the blocks covered in the digital communication system. Then we are having multiple access, multiplexing concept also. So the flow of signal processing steps shown in the figure represents only the typical arrangement. So these blocks, it is shown as a typical arrangement. It may be implemented in a different order also. Now next coming to the advantages of digital communication. So these are the advantages like ruggedness, flexible operation, integration of diverse sources, security. All these are the advantages. Reliable production of the signal, accurate processing. These are the advantages. These are only a list a few advantages. There are many more advantages of digital communication. So there is nothing called disadvantage. These are actually the limitations. Nothing but here bandwidth is high for channel, then synchronization is compulsory, complex circuit. These are the disadvantages of digital communication. Coming to the next topic is pulse code modulation. So it's very simple. As the diagram says here, PCM diagram, x of t is the analog signal. It is given to sampler and then it is quantized and then it is encoded. Then what we are getting is the resultant signal is the PCM signal. So it is given in terms of waveform also. The waveform, it is the analog waveform which is xt. Then it is sampled here. We can see the values here 1.2, 2.8, 3.7. All these are the sample values. Then they will be quantized or rounded off value. Then after that they will be encoded either 2-bit or 3-bit encoding technique, which is given here in this slide. So these are the sampled values. Then these are the quantized values. Then this according to this 1.5, it is 5 here. So as we draw this quantizer step size here, so 1.5 it corresponds to the level called as 5, and the corresponding 5 can be written using the 3-bit as 101. Okay, this is nothing but the PCM signal. So these are the PCM transmitter, then transmission path and receiver block diagram. Coming to next, quantization. So in PCM we have seen that the first one is the sampling, then second step is the quantization. So again, quantization we are having two types, uniform quantization and non-uniform quantization. So what is uniform quantization? You can see that in uniform quantizer the step size will be equal. Okay, the step size will be equal, and in non-uniform quantization the step size will not be equal. So this is the quantizer, that is staircase approximation diagram here given. Uniform quantization, we can see that the step size, it is uniform or same throughout the signal interval, whereas here in non-uniform, based on the signal amplitude, the step size is also varied. So we are having here next is the PCM. So PCM, it is a waste of bandwidth. That's why we go for differential PCM. So differential PCM, what we do, we just transmit the difference between two sampled version of the signal, and hence it is a much more simplified version of PCM. So here it is transmitted here, the error is transmitted, it is quantized and transmitted. So we can better explain this DPCM with the help of this diagram. So in this diagram, so here M of NTS is nothing but the sampled version. This is the predicted value. So subtracted this, we are getting the error. The error is quantized and then it is transmitted. So hence it is much more simpler than PCM. So coming to this next one is delta modulation. Delta modulation is again the advanced version of DPCM, where we are going to convey the information whether the signal is decreased its level or increased its level compared to the previous one. So just only 1 bit information it is transmitted. So 0 means the signal level is decreased, 1 means the signal level is increased compared to the previous step. So this is the simplest version here for transmission of the signal. Then this is the delta modulation transmitter and the receiver diagram. So in delta modulation we are having two errors, that is nothing but the slope overload distortion and granular noise, which is listed here in this slide. These are the various equations used for delta modulation. So the error regarding that delta modulation, slope overload distortion and granular noise, which is listed here.